Hello everyone, welcome back to our channel. So as we are discussing about the equilibrium, this is our third question. If you have not watched previous two videos, you can watch it on our YouTube channel. So this question was asked in the Mumbai University in December 2014. So first we'll read the question. A cylinder of weight 500 Newton. This is the cylinder of weight 500 Newton is kept on two inclined plane. So this is the first plane and this is the second plane. The angle of first plane is 50 degree. The angle of second plane is 30 degree as shown in figure. Determine the reaction at the contact points A and B. So they have clearly mentioned you should calculate the reaction at point A and at point B. So let's start with the solution. So first we will draw the FBD for the given sphere. So draw the sphere. So your solution will start from this point onwards. Then find the center of the sphere. Draw x-axis passing through the center and draw y-axis perpendicular to the x-axis. So this is your first quadrant, second quadrant, third quadrant and the fourth quadrant. After drawing the quadrants, we will start with drawing the weight of the sphere. So weight always shown from the center and it is in a vertically downward direction. So this is the a representation of the weight force. So the value of weight force is 500 newtons. So always start by showing the weight force. Then we'll show the reaction. Now we have got three rules to show the reactions. What are the three rules? The first rule is the reaction is always perpendicular to the surface in contact. So this reaction is perpendicular to the surface. If you consider this triangle, then this angle is 90, this angle is 50. So remaining angle will be 180 minus 90 minus 50. So it will be 90 minus 50, that is 40 degrees. So always you can write this angle as 90 minus this angle. So in this way you can find it, its value is equal to 40 degree. The second rule is your reaction should pass through the center of the sphere. And third rule will be the direction of the reaction should be towards the center, right? So I will repeat one more time. The reaction should be perpendicular to the surface in contact. Reaction should pass through the center of the circle and the direction of the reaction should be towards the center. So we had followed all the rules. Now we'll see what is the angle made by this reaction with the horizontal. So for that we'll draw x-axis here. So as you can see, this angle and these angles are called as a alternate angles, because this is a horizontal line and this also horizontal line and this line intersect these two horizontal lines. So this forms a alternate angle. So here we can write the angle value is equal to 40 degree. Now we'll show this force on our FBD figure. So this is the reaction RA and this is the angle made by the RA with the horizontal, that is 40 degree. Now we can transfer this force along its line of action as per the principle of transmissibility, and the angle made by this force will be same like 40 degree because these two are opposite angles. After representation of RA, we will represent the reaction at point B. So this reaction RB is perpendicular to this plane. Now the angle of this plane is 30 degrees. So here the angle of reaction will be 90 minus 30 degree. So this value is equal to 60 degree. Now this reaction is passing through the center of the sphere as well as the direction of the reaction is towards the center. So now this angle will be 60 degree. This angle and this angle is alternate angle. So here we can represent this reaction force on our FBD. So this is the representation of RB passing through the center towards the center. So this angle will be 60 degree. Now we'll transfer this force along its line of action. So it get transferred and here we got this force in the second quadrant. Now the angle of this force will be similar to this angle because they are opposite angles. So this is 60 degree. So in this way we have converted this figure into a simplified vector representation of the force. So here we have shown firstly the weight force in the vertically downward direction, reaction at this contact point perpendicular to the surface, reaction at the second contact point perpendicular to that respective surface. So here we got this simplified figure. Now we can solve this numerical by applying Lami's theorem. Why? Because the system is in equilibrium It consists of three concurrent forces and they pointed in the same direction. So it satisfied all the conditions of the Lami's theorem. So we'll start with applying Lami's theorem. So here we first consider the known force, that is 500 Newton, and opposite angle will be this angle between RB and RA. So it is equal to 180 minus 60 minus 40. So this is the value of 500 divided by sine of 80. The next one is RB. Remaining two forces are RA and 500 Newton. So included angle between them will be this angle 90 plus 40. So this is the value of angle 90 plus 40. Then last force is RA. The included angle between remaining two forces is this much. So that is 60 plus 90. So it is written 60 plus 90. Now in order to solve this numerical, we'll first equate 500 divided by sine 80 is equal to RB divided by sine of 130. Now we'll cross multiply it, right? To get the value of RB, we'll multiply 500 by sine 130 and divide it by sine 80. So by doing the calculation, we get the value of RB is equal to 388.93 Newton. Then we'll equate this side with the last one, that is RA divided by sine of 150. So 500 divided by sine 80 is equal to RA divided by sine 150. To get the value of RA, we'll multiply sine 150 to the 500. So 500 into sine of 150 divided by sine 80 is equal to reaction at A. Now this RA is equal to 253.86 Newton. These numericals can be asked for 5 marks in the final university examination. So try to understand how to draw the reactions at respective contact points. So it is very important. You cannot remember each and every problem, but you can remember the logic behind solving every problem. Now you can solve this numerical by applying conditions of equilibrium also, summation fx0 and summation fy0. If you find this video useful, you can like this video, you can share this video with your friends, and you can subscribe to our channel. Thank you very much.